Hi everybody. So today we're going to continue our conversation about enthalpy changes, endothermic reactions, and exothermic reactions. We've already talked about how we could tell if a reaction is endothermic or exothermic by looking at some of the key words in the description, the enthalpy diagram, and of course the enthalpy change. But what if you don't have the enthalpy change? Or what if it's not calculated for you? It's a new reaction that you discovered. Or you don't have access to the information. Well, we talked about how the enthalpy of a specific molecule was very hard to actually calculate accurately because there are so many factors involved. But you can approximate it using the bonds that make up the molecule. So if we could figure out the enthalpy of each reactant and each product, we can actually approximate the enthalpy change of our chemical reaction. So how do we do this? Well, the first step actually is to learn how to draw a molecule and expose what bonds it has. Because like we said, if we know what bonds it has, we can approximate the enthalpy of that molecule. So how do we do this? How do we draw a molecule? Now, from Sec 4, you saw the Lewis notation. That is the first step to do. Each atom in your molecule, you should draw the Lewis notation. Now, of course, you're wondering, well, that was Sec 4, sir. I don't remember Sec 4. Well, Sec 4 taught you that the Lewis notation was simply just you write the chemical symbol and you draw the number of valence electrons around it. What are the valence electrons, you might ask? Well, those are the electrons in the outer shell. And how we get those is by what group the atom is in the periodic table. Once you've got the Lewis notation of each of your atoms, you arrange the atoms in a symmetrical way around one central atom. Now, of course, you're wondering, but sir, how am I supposed to know which one is going to go in the center? Well, to be honest with you, it's kind of, once you start drawing out, you can kind of see the symmetry right away. It's very easy to see it. But if you're not sure, a very good helpful tip is that usually, but not always, the first atom in your chemical formula is the one that goes in the middle. So let's see an example of this. For example, methane here, CH4. Now, if you look at CH4, it's got one carbon atom and 4 hydrogen atoms. So immediately we can think of the symmetry in the sense that we could put the carbon in the middle and the 4 hydrogen atoms around. Putting a hydrogen in the middle doesn't really make sense because then it doesn't become symmetrical. As you can see here, I've put the Lewis notations of each of the each of the 5 atoms. The carbon is in the middle with the 4 valence electrons around it because it's in group 4. And hydrogen has 1 valence electron because it's in group 1. That's step 1. Step 2 now is to make the initial bonds. Now, of course, a molecule is atoms bonded together. If the atoms weren't bonded together, then we'd have free-floating atoms, which is not really a molecule. So how do we do this? So each atom must be attached to the central atom. So to be clear, each atom that's around the central atom must be attached to the central atom. How do we do this? We take 1 electron from the central atom and 1 electron from the outer atom and bring them together, just like I've done with the orange circle, the green circle, and the red circle, and the blue circle. Those 2 electrons, or that electron pair, will create a bond. And as you can see here, the electrons in the orange circle are replaced with an orange bond. The electrons in the green circle are replaced with a green bond. The electron in the red circle and the blue circles are also replaced with bonds. So 2 electrons make up 1 bond. Step 3 now is to check whether the octet rule was met or is met by every single atom. Remember that the octet rule states that each atom wants to have 8 electrons. Remember that each bond counts as 2 electrons, and hydrogen can only have 1 bond ever. So if you have a look at the structure we have right away, if you look at the carbon has 4 bonds. 4 bonds, 2 electrons per bond, means that carbon has 8 electrons. That means that carbon's octet rule is fulfilled. That's good. The octet rule for the hydrogen is also, all the hydrogens actually, is met because hydrogen, like we said, can only have 1 bond, and each of the hydrogens have 1 bond. Now, possibly, it's totally possible when we do other examples where the octet rule won't be met right away. And so what do you do? Well, what you got to do is you got to repeat step 2. You want to, again, take 1 electron from the central atom and 1 electron from the outer atom and combine them to make another bond. So you want to keep on making bonds with the central atom until the octet rule for each of the atoms in the molecule is met. We're going to see this in our next example if that's very unclear. So the example I have for you is oxygen gas, O2. So we start with O2. O2 has 2 oxygen atoms. And that's what I have right here, 2 oxygen atoms. Oxygen is in group 6, so each oxygen has 6 valence electrons. Like we said, our next step is to make the initial bonds. We're going to take 1 electron from each of the 2 oxygens, bring them together, and make 1 bond, just like you see here. Now, step 3, which we said was checking the octet rule. Has the octet rule, or is the octet rule fulfilled for each of the atoms here? Well, if you look at the oxygen on the left, it's got 1, 2, 3, 4, 5 electrons around, plus 1 bond. And we said 1 bond is 2 electrons. So that means that the oxygen on the left has 7 electrons. If we do the same analysis for the oxygen on the right, it also has 5 electrons around, plus 1 bond, which is 2 electrons. So it also has 7 electrons. So has the octet rule been fulfilled? It has not. Each oxygen only has 7. So we have to do something now about this. And we said our strategy was that, okay, if this happens, we're going to make more bonds. We make an extra bond every time until the octet rule has been fulfilled. So just like step 2, we're going to now take 2 electrons again, 2 new ones, combine them together, and make a new bond. Now the question is, has the octet rule been fulfilled? Well, let's have a look. The oxygen on the left has 4 electrons around it, plus 2 bonds. And we said 2 bonds. So 2 bonds times 2 electrons is 4 electrons, plus the 4 around it is 8. So that one has been fulfilled. We do the same analysis again for the oxygen on the right, and yes, the octet has been fulfilled for that one too. So this is our final structure. The key thing I want you to notice here when you're looking at this is oxygen does not have 2 single oxygen bonds. It has a double bond. That is a double bond. It looks like it's 2 singles, but actually it's a double bond. Let's do one more example. This time the example is nitrogen gas, N2. So again, the starting step is to have the Lewis structures, or sorry, Lewis notations for each of the atoms, the 2 nitrogens in here. Nitrogen is in group 5, which means it's got 5 valence electrons, like I've drawn out here. And immediately our next step, like we said, is to make that initial bond. So grab 1 electron from each of the nitrogens and make a bond, so they're connected. Now we have to check, are they happy? Has the octet rule been fulfilled? Well, let's have a look. The nitrogen on the left has 4 electrons around it, plus 1 bond, which is 2 electrons. So that's a total of 6. So the nitrogen on the left has 6 electrons, and if you do the same analysis, you'll see that the nitrogen on the right also has 6 electrons. So they are not happy. The octet rule has not been fulfilled at all. So what do? We repeat step 2. We make another bond and hope that solves the problem. So we grab another 2 electrons that haven't been used yet, make a bond. So now we have a double bond between the nitrogens. If we do that analysis again, the nitrogen on the left has 3 electrons plus the 2 bonds, which is a total of 7 electrons. Same goes for the nitrogen on the right. So has the octet rule been fulfilled? No, it hasn't. So we have a problem again. Well, what do? Well, we repeat step 2 again. We're going to try to make another bond. So we grab another 2 electrons and make a bond. And now, looking at this, now you could see that each nitrogen has 2 electrons on the outside plus 3 bonds, which is 6 electrons. So in total, each nitrogen has 8 electrons, which means this is our good structure. The octet rule has been fulfilled. Just like in the example we saw with the oxygen, this is the way to interpret this is not 3 single nitrogen-nitrogen bonds. In fact, this is a triple bond between the 2 nitrogens. So just be clear about that. All right, so we've done 2 examples, and now it's your turn to practice here. These are 4 very, very common compounds you're going to see in reactions. Give it a try. The answers will be posted so you can check your answers and see where you went wrong. Or, of course, if you've already got it, that's perfect. So give it a try because you're going to need some of these for the next part of the video.